Welcome to The Explainer. Today, we're dissecting a medical mystery that is literally forcing researchers all over the globe to completely rewrite everything we thought we knew about disease, aging, and our modern world. We're looking at the alarming global paradox of early-onset cancer.
Okay, let's dive into this. Historically, we've kind of always thought of cancer strictly as a disease of aging, right? Like, it's a process where decades of cellular wear, tear, and genetic mistakes finally just catch up with us. But today, that biological expectation is completely being shattered. So the defining question we really have to answer is, why is youth no longer a force field against cancer?
Well, according to data from Dr. Y and Nancy Yu at the MD Anderson Cancer Center, back in 2009, the average age of someone diagnosed with colorectal cancer was 72. But today, that average has dropped to 67. And what's even more startling is that early-onset colorectal cancer has rapidly become the leading cause of cancer death for young adults in the United States. It's a massive shift. And look, this isn't just some anomaly isolated to one single disease. Since the year 2000, we've seen a really sharp spike in over a dozen different cancer types in the under 50 demographic. We are talking about significant upward trends in colorectal, breast, and uterine cancers, alongside others like kidney and pancreatic cancer. It's happening across the board. This brings us to our very first major clue, the birth cohort effect. So for decades, cancer risk had a pretty predictable baseline. But starting with people born in the 1950s, that baseline risk actually began to rise. Then it accelerated noticeably for those born in the 1970s. And get this, if you were born in the 1990s, your risk of developing early-onset colorectal cancer is roughly double what it was for someone born in the 1940s. Basically, every single generation born since 1950 carries a compounding accelerated risk. This proves we're dealing with a relatively new, escalating biological phenomenon.
So, could it be a red herring? Is it simply genetics? Now, what's really interesting about this slide is that it's supernatural to assume inherited DNA is to blame here, right? But genetics actually represents a surprisingly small piece of the pie. Data from Memorial Sloan Kettering Cancer Center shows that even in patients under 35, germline mutations, inherited genetic changes like BRCA or Lynch syndrome, they only account for about 20% of cases. The vast majority, a staggering 80%, are actually driven by environmental and unknown factors.
Dr. Ulrike Peters puts it perfectly. Genetics cannot explain the rise we have seen in early-onset cancers. Our genome just doesn't change so quickly over several decades. And it's true. Human DNA simply does not mutate fast enough to cause a massive population-wide spike in just a few generations. So that forces us to look completely outside the human body.
That means we need to start uncovering the prime suspects, because if human DNA hasn't changed, our world absolutely has. To really solve this, we need to understand a crucial, emerging concept in cancer research called the exposome. The exposome is defined as the theoretical totality of all the environmental and lifestyle factors an individual is exposed to over their entire lifetime. It's the whole shebang. Researchers believe that this whole package of modern factors is compounding to create a biological window of opportunity for cancer to take hold in younger populations.
Let's look at suspect 1, our modern metabolism.
The evidence linking our metabolic health to early cancer drivers is actually really substantial. For instance, obesity induces a state of chronic, low-grade inflammation, which alters our body's hormone levels. Then there's the sedentary lifestyle, which is now known to increase the risk for at least 13 different cancer types. And of course, the Western diet, heavily reliant on ultra-processed foods, is actively altering our gut environment. Put all that together, and these metabolic factors act as an incredibly powerful engine for cellular damage.
And here's the thing, that metabolic impact isn't evenly distributed. Take a look at this startling statistic from the American Cancer Society's 2025 report. Women under 50 now have an 82% higher incidence of cancer compared to men in that exact same age bracket. Experts attribute this heavily to obesity-driven cancers, particularly uterine and breast cancers, where metabolic changes heavily influence hormone production.
Moving right along to suspect 2, the gut microbiome.
Let's move to and see how this builds biologically on a cellular level. Recent studies have actually uncovered a direct link between childhood exposure to specific strains of E. coli bacteria and colorectal cancer. So here's how the mechanism works. The bacteria release a toxin called colibactin. This toxin goes in and directly damages the DNA of our gut cells. Now, in younger bodies, this damaged gut tissue tries to heal by reverting to a vulnerable stem cell-like state. And unfortunately, that state is a prime breeding ground for cancer to emerge in youth. It's a brilliant, yet totally terrifying example of how a microscopic change in our environment alters our very cells.
And that brings us to suspect 3, the modern urban exposome.
We live in a post-World War II, industrialized world that is just saturated with unseen synthetic variables that earlier generations literally never faced. Think about it. Microplastics are now found in our food, our seafood, and even household dust. PFAS, the forever chemicals, are contaminating drinking water supplies. We're constantly breathing in fine particulate matter, like PM 2.5 from heavy traffic. And we actively absorb chemical compounds known as PAHs from everyday beauty products and food flavorings. The sheer volume of these toxins compounds over a lifetime. And the scary part is, that exposure often begins while we're still in utero.
So when you synthesize all this data, it leads to one powerful analogy that perfectly frames this whole mystery. Genetics might be the loaded gun, but the modern environment is pulling the trigger. Our inherent biology is just being completely bombarded by a complex exposome that simply didn't exist a century ago.
So, solving the modern mystery. Where exactly does this leave us?
Well, there is some good news. One of the most immediate victories is happening right now in preventative care. Recognizing the severe threat of early-onset colorectal cancer, the medical community successfully lowered the recommended screening age from 50 down to 45. And this simple, data-driven change resulted in a massive 62% increase in screening for this younger demographic. It's a real game changer because it allows doctors to catch precancerous growths early when they're highly treatable.
The reality is, there's no single smoking gun for early-onset cancer. But global research initiatives, like the National Cancer Institute's Prospect program, are actively diving deep into the biological mechanisms to find actual answers. We're also seeing a massive push for awareness around metabolic health and the real dangers of ultra-processed foods. Plus, there's a growing, absolutely crucial movement toward reducing our daily exposure to environmental toxins.
And this brilliantly illustrates the path forward. Just like Dr. Andrea Sursek said, the more data we gather, the clearer this becomes. We are getting outside our niches and thinking about this from new perspectives. It really is a unified global effort across multiple scientific disciplines to solve this giant puzzle and ultimately improve survival rates for young adults everywhere.
Which brings us to the most important question of all. Knowing that your lifetime exposure really matters, and that cancer is definitely no longer just a disease of old age, what hidden factors in your daily exposome can you change today to protect your future? I want you to really think about what's on your plate, what's in your water, and how you move your body every day. Thank you so much for joining me for this explainer. Keep learning and stay focused.